Okay, so today I'm going to cover 4.6. This is the last section in this chapter, and for this test, modeling with exponential and logarithmic equations. So the first one, we are going to solve literal equations for a specific variable. So the first problem number 1, it says solve for d from the equation. From the equation f equals 23.5 plus 2 times log d. So we have to solve for d means from this equation we have to get the d by itself. So what do we do first? First we have to move this 23.5 to the other side. So we get s minus 23.5 equals 2 times log d. So I have to get the log d again. So we have to remove the 2 to the other side. So we're going to divide by 2. Equal to log d. Since we have to solve for d, and this is a logarithmic equation, we have to convert into exponential equation. So the base is 10. So we get d equal to 10, and this whole thing goes to the top. So this is our final answer. Next, number 2, we have to solve for x from the equation. So the first one was the exponential equation. The first one was the log equation. The second one is the exponential equation. So we have to solve x. That means we have to get the x by itself. So let's first move the t to the other side. Now we have to divide by 3 first. Since it's an exponential equation, we have to take ln both sides to get the x. And we have to bring the power, and ln e is 1. So I have to get rid of the n, so I have to divide both sides by n. So we get x equals, just going to write 1 over n ln of 4.23 and and it's given in our handout as well. You can check that. The next one is a word problem. We have a couple of more word problems, then we are done with this section. Number 3, it's given, suppose that 19-year-old Win 100,000 playing the lottery. If you would like to have 1 million when you reach age 67, determine the average rate of return needed. So there are two formulas we are going to use for a growth, for exponential growth. We have to use y equals y0 e to the power kt, where k is a constant. And for exponential decay, we have to use the same thing. Here, k is negative constant, and here k is the positive constant. That's the only difference. Okay. So let's take let's do problem number 3. So well, this problem number 3 is already, we have learned this one. We have to use the formula, the compound continuous compounding. So A is given as 1 million, and P is the principal amount, how much you are investing, it's 100,000, and T is, when you retire 67 minus 19, so T is going to be 48. So we're finding the rate. So let's plug in the numbers. Equals e to the power, we don't know what the r is, and t is 48. So when you divide both sides, so we cross the zeros, we get 10 equals e to the power 48 r. So we have to get the r. So take ln, because the base is e. Let's take ln both sides. And so we have to move the power. And ln e is 1, we know that. So get the r, divide by 48 both sides. And use your calculator, you get 0.048, or it's going to be 4.8%. That is the rate, average rate of return. And number 4, we have the problem is given. Please read the handout. So I'm just going to solve the problem. The P0 is the initial amount. So that is given as 20. And we have to find, and we are also given P of 14 is given as 378. because it says 20 pythons were recorded as captured or killed in 1995 by 2009. So between 2009 and 1995, the number of years are 14. So minus, when we subtract, we get 14 years. So that is given as 378. Now we have to find the rate. So let's plug in. So this is the formula. P of t is, we're going to plug in all the numbers here. So it's going to be 378. P0 is 20. E to the power. We don't know the word. R is, T is 14. So now we get 378 plus 2. So divide both sides by 20. And we get 18.9. And take L on both sides. So we get R equals Ln 18.9 over 14. So you will get R equal to 0.01. Okay, so we got the R. The next part, it says use the model from part A to approximate the number of pythons captured or killed in 2017. So from 1995 to 2017, T is going to be 22 years. So we have to use this model. This is the model, but we got the R. We have to find P of 22 is 20 times e to the power. R is 0.21 and T is 22. So when you enter on your calculator, you get 2030, and it's the number of snakes. So that is the answer. In 22 years, 2030 snakes will be captured. Then part C, we have if the ratio of the pythons living in the wild to pythons captured is approximately 100 to 1. How many pythons were estimated to be in the Everglades in 2012? So 2012, so again T equals 17 from 1995 to 2012. And so P of 17 equals 20 times e to the power 0.21 times 17. Enter on your calculator. You get 710 captured or killed. So since it's 100:1, so we have to multiply this by 100. So that is going to be 71,000 snakes. Okay. And the last problem for this chapter is we are given, it's about the sample collected from cave paintings on an archaeological site in France showed that 2% of the carbon-14 still remains. How old is the sample? So we have to use the model. Q of t equals Q0 e to the power 00121t, where Q0 is the original quantity. So it's the 2%, 2% it's still remaining. So that means 0.02 of the original, which is Q0. And then we can cancel both sides. We can divide both sides by Q0. So we get 0.02 equals now we have to solve the equation. We have to get the t. So take L on both sides. And so we're going to bring this one to the front. And ln e is 1, we know that. So to find the t, we have to divide both sides by this negative number. That gives t is going to be 32,301 years.